Momentum. It's the product of an object's mass and velocity. It's both of those combined. The formula is P is equal to m times v. And notice that all three letters are lowercase. So momentum has direction, and that's because velocity has direction. And the units of momentum are kilogram meters per second, because those are the units of mass and velocity. Kilogram meters per second. Now let's compare the momenta of two objects. Momenta is the plural form for the word momentum. So example, car 1 has a mass of 1,200 kilograms moving at 15 meters per second. Momentum is just the product of those two numbers. So 1,200 times 15 is 18,000 kilogram meters per second. You'll notice that momentum has very large numbers. Car 2, a smart car, has only 880 kilograms, but it's moving at 22 meters per second. So its momentum calculates to be 19,800 kilogram meters per second. You would think a smart car has less momentum than a large Camry, but if it's traveling fast enough, its momentum can exceed the momentum of a large, slow-moving car. So car 2 is harder to stop because it has more momentum. So another example, let's compare two football players. So football player 1 has a mass of 125 kilograms and he's stationary. So his momentum is 0. There's no momentum because he's not moving. Remember, momentum depends on the product of mass times velocity. Player number 2 is 100 kilograms in mass and he's moving at -5 meters per second. So that means he has a momentum of -500 kilogram meters per second. See, the negative sign just indicates the direction of the momentum. Direction of the velocity is negative, so the momentum is going to be negative also. It's just the direction. Now, lastly, I want to emphasize that it takes an impulse to change the momentum of an object, and that is going to be our next lesson.